So group 1 reactions down the periodic table, the electron is further and further away from the nucleus, so it is more and more reactive, so it's easier for them to lose the electron, which is what they want to do. And so you see lithium is further up. There was quite a bit of effort to cut it, and you can see it was quite shiny and it quickly tarnishes. That one's black, so you can see it go slightly more and more black there. Now it's even less shiny, and now it's kind of blackish. All right, the other two are harder to see because their oxides are not a dark color. They're sort of the white and silvery, which is very similar to the shiny when you cut them. So this one, you can see I'm not like going back and forth with the knife. It just slices with one little tap. You can see it's a little bit shiny and starting to go a bit whitish. And the potassium will be even quicker, and the potassium cuts even easier. Okay, because they're quite large atoms as we go down, so they're larger atoms. See, that just slices quite nice without even you can't even hear the knife hit the ceramic tile. Okay, it tarnishes straight away. So they're less dense, lower melting boiling points because they're larger atoms, and more reactive because they're larger atoms, so the electron escapes easier. Now, this time we're putting them in the water, and so the reaction is, as you can see here, the reaction is producing a base and hydrogen gas, and so it melts and goes into a little ball, floats on the hydrogen, and turns the water basic. And so you should see them get more and more reactive as we go along. So this one takes the longest, it's the slowest reaction. And there's a little bit of anomaly here. So there's a few errors here. Number one, they're not exactly the same size pieces. Some of them have more tarnishing on them. So they're older samples. They're covered in oil. They're not evenly dried either. And I think with the sodium, I sort of hit it into the water. This one is way too quick. So that one just blows up straight away. That's meant to be less reactive than the potassium. So my students claim potassium's still more reactive, they say, because it catches on fire, whereas that one didn't catch on fire. So normally they are clearly more reactive. So this one here is sputtering and the hydrogen catches fire. And usually that's the potassium reaction, and the sodium's somewhere in between lithium and potassium. Okay, so I hope that's helpful.